So good evening, so good afternoon everyone and welcome to today's lecture. In today's lecture, we are going to deal with Newton's second law of motion, and we have seen F is equal to ma, and F can also be written as dp by dt. Yes or no? Do we remember this? Yes or no? Okay, now let us go ahead and solve one or two more problems on this momentum thing, so that we understand what type of problems are going to come. These are the problems that we are solving. Similar problems are going to come in your exam, so please be attentive and solve them. Once you get used to them, they are pretty simple, and they you will see that which solve one question here. Vehicle of 10 kg, we have done this. Okay, let me then give you this question. Let me then give you this question, and the question comes on your screen straight away. This is the question. A force of 10 Newton acts on a body of mass 20 kgs for 10 seconds. Find the change in its momentum. I hope you can see the question, bacha. Oops. You can see the question. A force of 10 Newton acts on a body of mass 10 kg, 20 kg for 10 seconds. Find the change in momentum. I'll give you 2 minutes to solve this.
Option B. What is the everyone got 100 km per second? What's the number? What's the
Yes, beta.
Option B, sir.
Option B. How did you get option B? Option B is correct. How did you get option B? You must remember force is rate of change of momentum. Yes or no?
Yes, sir.
Instead of writing it as dp by dt, you can also write it as change in momentum divided by time. Yes or no?
Yes,
So
sir.
your change in momentum becomes f multiplied by t. Yes or no?
Yes, sir.
You multiply f by t. So how much is f? F is 10 multiplied by 10. Change in momentum will be 100 kg meter per second. Do you all understand this? Everyone, please give me a raise hands that we understand this. Yes or no? Now, what is this change in momentum known as? We will do it in today's class also. But since we are doing change of momentum, so let me just carry on with that thought process and give you more questions. Remember, these are the type of questions that are going to come in your exams, beta. Simple questions. Let me see what to do with this one. Somewhat different. Let's see if you can manage this one. Read the language of the question. You might find the same question in examination, or don't worry, you know how to solve it. A train is moving with a velocity of 20 meters per second. On this, dust is falling at the rate of 50 kg per minute. What is the extra force required to move this train with a constant velocity? Question has been changed. Velocity is constant, hai? Velocity is constant, but then something else is changing. I'll give you 2 minutes to think about this. Shall I help you, or you will be able to do this? Hmm? You want more time? Okay, I'll give you 2 more minutes. Yes, bacha? Can't hear you. Shall I do it? Okay, let me help you out probably.
Option A, sir.
Option.
B, sir.
Someone is getting option A, someone is getting option B. Okay. Now just remember this, what we are writing here. Now, when we wrote force as dp by dt, it is the rate of change of momentum. It is absolutely correct. So that is, it is rate of change of m into v. Now, in most of the cases that the question that we do, mass remains constant and velocity changes. So it looks like this: mass is constant into rate of change of velocity, and it becomes m into a. This is the case that happens normally. But sometimes, as in this question, as you can see, velocity has to be kept constant. Something else is changing. What is changing? Here the mass of the train is changing, my dear friends. So if the mass is changing and velocity is constant, then I can do this in this way. So dp by dt, d by dt of m into v. In red equation, m was constant, it comes out. In this equation, v is constant, so v into dm by dt. Do we understand this? So we multiply the velocity by the rate of change of mass. So we do this. 20 multiplied by the rate of change of mass multiplied by 50 20 multiplied by 50, and the answer is 1000 newtons. How many of you got this answer? 1000 newtons. No one got this answer? That is the wrong answer. Because what we have not seen here with our eyes is this is kg per minute. In 1 minute, 50 kgs. The SI unit is not minute, it is seconds. So you have to convert minute into second. 50 kg per minute has to be changed into 50 kg per second. Into kg per second. So we have to divide it by 60. Do we understand this? So the only thing that you have to understand here is the unit. Yes or no? Now our answer drastically changes from option B to option A, and that is the correct answer, option A. Everyone got this? Yes or no? No, yes? Okay, now is the time that we move forward and we do more questions. One more question is there. I'm covering all types of questions that have ever come in your NEET exam, so that if you see any question, you would say, okay, we have already done this question in the class, so don't need to worry about it. Anyways, and where is that question that I just saw? Here is the question. This is a very pet question of your NEET exam. Very pet question. They've asked this several times in different ways. This is one of those questions. Sometimes they change the value, but again they give you the same question with values changed. So do it, because you are going to be doctors or you are going to treat patients who are going to get hit. So this is a cricketer who has been hit, and cricket I think is going on. A cricket ball of mass 150 grams is moving with a velocity of 12 meters per second, is hit by a bat. So the ball is turned back with a velocity of 20 meters per second. The force of blow acts for 0.01 seconds on the ball. Sometimes they give it, instead of ball getting hit, someone is catching it. So these are the two ways in which they give it. The average force exerted by the bat on the ball is, and I'll give you 2 minutes to do this. Question number 2 or 3. I've forgotten the. Anyone with an answer? Shall I do it for you, bacha? Are you trying? It's all about calculation, nothing else. Shall I do it for you, bacha? Okay. So what we need to find out, what all things are given to you. This is the mass of the ball, M, 150 grams. So we can divide it by 1000, 0.15 kg. Yes or no? This is the initial velocity U. It is, let us say, moving like this. So let me call this as positive. It is hit by a bat, so that ball is turned back. So this is the final velocity V. If the initial velocity was like this, the final velocity will be like this. Yes or no? So it will be taken as negative. This is the time. What is the average force? So how do I find the average force? Force is change in momentum divided by time. M into V minus U divided by T. Yes or no? Mass is 0.15 multiplied by final velocity is minus 20. Yes or no? Minus initial velocity is 12 divided by time is 0.01. You just have to subtract. It is not getting subtracted, they will get added, and then multiply and divide. You can do that, yes or no? What is the answer that you are going to get? The answer that I have is 480 newtons. Are you getting it?
Yes, sir.
Well done, and congratulations, you got the answer. Everyone understood this? Can I have raised hands? Great. Only girls are understanding. Boys, I don't know what they are doing. Boys? Yes, we are there. Okay. Good to know. Okay. Since we are talking about force, time, and momentum, this is the time when I can also understand these questions, because these questions come in NEET anyways. Impulse. So that is the next heading for today, impulse. We denote this impulse by the letter I. What do you mean by impulse? There are different ways in which you can define impulse.
Force into time.
Yes, beta?
Force into time.
Yes, you can call impulse as force into time, but the better way of calling this impulse is I vector is integral of
Change in momentum.
yes force. In very simple terms, you can call it force multiplied by time, but this is the actual meaning of this impulse. It is the integral of force into time. Or you can also call impulse as change in momentum of a body. Impulse is final momentum minus initial momentum. It is a vector quantity. Impulse is a vector quantity and its direction is same as the direction of force. It's SI unit. You can also call it Newton multiplied by S second. Or you can also call it kg, meter per second. The dimensions are m, l, t minus 1. The dimension is same as the dimension of momentum. Then sometimes you will hear this term impulsive force. So let us write impulsive force also here. Impulsive force is a force of very large magnitude acting for a small time. You have just seen ball hitting the bat. The force was acting for a very short time. It was a large force, 480 newtons, very large, but acting for a very small time. Such forces are known as impulsive forces. Do we understand this? Questions have come on this impulse. That is why we are doing this. I'll give you 2 minutes to note this down. We noted it down, everyone?
Yes, sir.
Okay. Now, there's some more things that we'll need to note down here. If you have a force time graph, a graph between force and time, this graph may be like this. It could be a triangle, it could be a rectangle, it could be a trapezium. If you have a FT graph, force time graph, the area under this graph gives us the impulse. The area under force time graph gives us the impulse. Why it gives us the impulse? Because impulse is the integral of f dt. Integration means area of graph. Impulse is the integral of f and dt, f and time. Therefore, area under force time graph will always give us impulse, or you can also call it change in momentum. So area under force time graph, many questions have come on this. Area under force time graph will give us the impulse or change in momentum. Do we understand this? Then there is a small thing which is known as impulse momentum theorem. We have already done this, but let us also do it as a heading. impulse momentum theorem. And what does this impulse momentum theorem tell us? It is very simple thing. It tells us that impulse vectorly, if I write, it is change in momentum. Final momentum minus initial momentum is your impulse, which is nothing but F multiplied by T. This statement is known as the impulse momentum theorem. Do we understand this? Yes or no? This statement that
Yes, sir.
is known as impulse momentum theorem. I'll give you 2 minutes to note this down.
Completed, sir.
Everyone done? Boys? Shall we move ahead with the questions? Here is the first question, and I'll give you 2 minutes to solve it. Simple question. Previous year questions, I told you many questions have come. 2 minutes to solve this. A body of mass 150 grams is moving with an acceleration of 20 meter per second square, is hit by a force which acts for 0.1 seconds. What is the impulsive force? Give you 2 minutes to solve this. Anyone able to do it, or shall I help? Shall I help you, bacha?
ఎట్లా అంటే చెప్పండి ఇంటూ 0.1 చేసినావా ఇంటూ 0.1 చేసి ఇంటూ 0.3 వస్తుంది
Anyone got the answer? No one? It's a simple question. You just have to apply. See, these questions have come in your exam many times and they get repeated over and over again. They don't make new questions, they just give old questions.
0.3, sir. Newtons per second.
0.3 sir, Newton per second. And that is the correct answer, sir. Well done, sir. How are you supposed to do it? To find the impulse of the force, bacha, you have to take out the force and multiply it by the time. Mass is given to you, m.
0.15.
Acceleration is given to you, and time is given to you. To get the impulse, you find out the force, which is mass into acceleration, and multiply it by the time t, and you are done, my dear friends. Only thing you have to remember, it is 150 grams, so convert into kilograms, 0.15, multiplied by acceleration is 20, multiplied by time is 0.1, and you have your impulse, 0.3 Newton second. How many of you got this one? Only girls? Okay, boys are also there. Boys are not behind. Can I give you the next one again? Same questions have come many times in your exam. So that is why I'm doing this part here. Else I actually cover this impulse part in the chapter on center of mass. But for you guys, I'm doing it here. A force of 50 dienes. Diene is the CGS unit, remember. A force of 50 dienes acts on a body of mass 5 grams, which is at rest for an interval of 3 seconds. What is the impulse? You have 2 minutes to do this. Yes, my dear friends, what is the answer? Impulse is force multiplied by time. Just do it. Force is 50. Time is 3 seconds. Answer is 150. But 150 is not there. Why is 150 not there? Because it is not in CGS unit. This is not in MKS unit. This is given in CGS unit, Diane. So you have to convert Diane into Newton. And how do you convert Diane into Newton? You multiply it by 10 raised to the power minus 5. That is what you have to remember. Then multiply it by 3. So it will be 150 into 10 raised to the power minus 5. Now you can get your answer. What is the correct option?
Option C, sir.
Option C, sir. So you should have told that, na, sir. Before me telling you all this, na, sir. Anyway, sir, do we understand this? These are the things that come in the examination hall, and that is why I'm specifically doing only those questions which have come and have come many times. Do we understand this? See, the questions that come in the exam are so simple. They are straightforward. Straightforward. Impulse, force into time. Impulse, force into time. Impulse, force into time. Shall we move on to the next one? Huh? This one. The force time ft curve of a particle executing linear motion is shown. The momentum acquired by a particle in the time interval from 0 to 8 seconds is. Yes, bacha. Any answer? Yes. Now remember how you do question like this. The area under force time graph will give us the change in momentum. Yes or no? So basically what you have to find out is this area, the red one, this area, the blue one, and this area, the blue one. Now this is a sine curve. Now it's very difficult for you as medical students to find out the area of this graph. They are not asking you the area of this graph. Probably they're just asking you the logic. Now you see this area, the red one, that is what I did. It is above time axis, so this area is positive. Do we understand this? The area that is here below the time axis, that is negative. Do we understand this? Now remember, area above time axis is positive, area below time axis is negative. Now if you look at this sine curve, I have not drawn it properly, but whatever area is from here to here, remember that the same area will be from here to here. Yes or no? Whether it is a sine graph or it is a cos graph. Cos graph is like this. In one cycle, whatever area it has on the top, the same area it has on the negative cycle. That means the net area, if we talk about positive and negative, the net area is 0. Do we understand this? Net area is 0. That means there is no impulse. There is negative impulse. There is positive impulse. Both cancel each other out. And therefore, the correct answer is option D. Do we understand this? So note this down as an important point. Have we noted this? Yes or no?
Yes, sir.
Everybody understands this?
Yes, sir.
Okay, I give you one or two more questions on this because these questions come. This one. The kinetic energy of two bodies of mass m1 and m2 are equal. What is the ratio of their angular momentums? Yes, anyone with an answer?
Option B, sir.
Option B, sir, is not correct, sir. Okay. So, before going any further, whatever questions we are doing, we are noting some important points in that question. What is the important point here? Now, we don't know what is the kinetic energy. Anyone knows what is kinetic energy? You must have heard about this. We are not done this topic now, kinetic energy, but you know what is kinetic energy. Kinetic energy of a body Ke, or simply I call it K, is equal to half mv square. Yes or no? Now, these type of question come many times in your NEET. That is why we are doing it. Kinetic energy is half mv square and momentum is m into v. Yes or no? We can find out a relation between K, kinetic energy, and momentum P. I can write kinetic energy as P square divided by 2m. Yes or no? No or yes? You can write it like this. I can write kinetic energy as P square by 2m, kinetic energy in terms of momentum, or I can write momentum is 2m k ka root. Yes or no? Left hand side equation is kinetic energy returns in terms of momentum. The right hand side wala equation is momentum return in terms of kinetic energy. Do you understand this? Now, can you answer this question? Question number 27. I'm waiting, bacha. These questions are going to come in your exam. I'll give you 2 minutes to do it now.
Option C.
Option C. Now the answer changes from B to C. So now from this equation, the pink equation, we can see kinetic energy of both the particles are same. So I can say momentum will be proportional to root over mass. Yes or no? So momentum of body 1 divided by momentum of body 2 will be root over m1 by m2. Do we understand this? Yes or no? No, yes. Let me ask the question in the reverse way and let's see if you can do this. Everyone has noted this down? I've seen the reverse question as well. I don't have it with me, but I will make the reverse question for you. And I hope that you can answer the reverse question. The reverse question of this. Momentum of two particles of mass m1 and m2 are equal. Find K1 by K2. Do you understand the meaning of K1 by K2? Ratio of kinetic energies of 1 divided by 2. We understand this question? Yes or no? No or yes? You have 2 minutes to solve this. Options are not there because this question I have made. Anyone with an answer?
ఏమొద్దు ఎవరు చెప్తున్నారు
Anyone with an answer, my dear friends? No one with an answer? Shameful. Shall I do it? Huh? No one is giving me an answer. What happened, bacha? The answer will come in terms of M1 and M2. So options might be M1 by M2, M2 by M1, root over M1 by M2, root over M2 by M1. Can you now give me an answer? Option would be like this. No one? Still no one? Well, then I will solve it for you.
M1 by M2.
K1 by K2 is M1 by M2 or the reverse of it? Okay, it seems like everyone has given up. So now it's my job to do it for you, bacha. We know the formula. Kinetic energy K can be written as P square by 2M. Do we understand this? Now remember, both the momentums are same. So I can write K1 will be equal to P square divided by 2M1. K2 P square divided by 2M2. Once I divide bacha K1 by K2, what would I get? What would I get? I would get M2 by M1, and that is the answer, beta. So when the energies were same, momentum was in the ratio root over M1 by M2. When the momentums are same, energy is in the ratio M2 by M1. Did we get the question and the answer, bacha? We understand this, yes or no? Okay then, so we'll wind off this class here. We have done with your 4 basic questions. In the next class, we'll solve some question on bodies which are connected to each other. These questions also come. We'll try to wind up in the next class and probably start with friction and try to wind up your Newton's laws, more laws of motion. I hope you have understood what we've done in the class. Take care. Have a nice day. God bless you all. I'll see you tomorrow. Bye bye. Everyone, everyone is trying the question from the sheet. You have got the sheet for NLM? Newton laws. Did you get the sheet for Newton laws?
No, sir.
Okay. I'll get it.